even though we've dealt with volumes of rotation before, starting with 6.1 and then continuing on in 6.2, I wanted to go over some of this again as a quick review because it's been a while since we talked about it. First off, just remember that and I think the first one we'll deal with is 6.1, which is nicknamed disk and washer. And they're called this because we can imagine the situation where we have some function, and what I happen to draw here is y is equal to the square root of x, more or less. And we want to rotate this around the x-axis. And when we rotate this, we can imagine it's creating a volume. And I'm just going to draw a little base for it here. Let's see here, something, you know what I'm talking about here. It's very hard to do. But it's like a projectile, a bullet, or something like this. And we can imagine at some point here there is a cross-section that looks something like this. Okay? And we can imagine there's an infinite number of cross-sections as we go along. Now, this right here, this cross-section, is the disk that we're talking about. Now, how are we going to use that disk? How is this going to be involved? Well, if we come over here for a second, let's digress for just a moment and consider a cylinder. Here's a cylinder. It's got a round cross-section, and it has a radius. This base and top have a radius. And the question is, what is the volume of this cylinder? Okay? What is the volume of that cylinder? Think about that for a second. If we give that the radius is, let's call it r, then the surface area of the top and bottom is equal to pi r squared. Okay? That's just the area of a circle. And then we figure the volume by saying, well, this cylinder's got some height, so it's pi r squared times the height. Cool. Now on our disk, our cylinders, this equation applies, but we're going to talk about it just a little bit differently. Let's draw our cylinder a little differently as a washer. And so I'm going to represent it here as having a kind of a, I'm flipping this over on its side. So now it looks like this. It's still a cylinder. It still has a now height. Maybe we should start talking about this as a thickness of our washer. Okay, we're going to call it, but we have a center. We have a radius. We'll still call that r. The thickness now, because it's along the x-axis, it's running parallel to the x-axis. This thickness, it's this thickness right here. We're going to call that delta x or delta dx, either one. Okay, maybe best to call it dx. So what is the volume of this little disc, this washer? Well, it's just going to be pi r squared dx. Okay? So whenever we see these, it's going to be important to determine, is it going to be dx or dy? What do I mean by that? Well, when we set up the problem, in this case, when we set it up, we're rotating around the x-axis. Therefore, the thickness of the disk is parallel to the x-axis. Therefore, we're talking about d-axis. On the other hand, if I had said, and I could have said this, let's rotate around the y-axis. Now, this will give us a very different looking thing, something that kind of looks like a, I don't know, a solid funnel, or something that goes around in this direction. Okay, it looks kind of like this coming off the page. And now we have our thickness of our disk. The thickness is parallel to the y-axis. Because it's parallel to the y-axis, now we're not talking about dx's, we're talking about dy's. And that's going to affect the way we set up the problem. So one of the first things you need to know is how to calculate the volume of a disk. That we got. The second thing you're going to need to know is this disk going along so that it's a dx, in other words, the thickness is parallel to the x-axis, or is it parallel to the y-axis? And that's going to affect how we set up the problem.